Oh, good afternoon. I'm trying something different today. I'm going to try a mic and speakers instead of the headphones. I don't really like how the headphones feel. So, all right. I have to turn my volume is up though. There we go. I have audio. So Max.
Hello.
Hey everybody. So I'm trying something different. I'm like using my fancy mic. Oh, fancy. Makes me feel cool. But I'm gonna try that instead because I have like so many classes today and I don't like how the noise canceling beats like feel when I'm talking because I like have to talk like super loud over them. So just finishing up one post here for my other class. I should get the chat up too. Man. Anybody done yet? Like for other classes, have you turned in final stuff yet? Hey, Natalie.
Not yet.
Nothing yet?
Yeah, my physics finals is tomorrow. That's about it.
Are you doing it like ours, where it's like do it on your own time?
No, it's like in D2L, like in the quiz section, and it's timed. So
Gotcha. Yeah, like that's definitely one thing. Wait. I'm like not. One thing that I saw in some of the comments people gave to the survey, super valuable, by the way, really interesting feedback. If you haven't filled out the survey, I'd really appreciate your comments. I've got some really thoughtful comments there, but one thing I was asking about was the timing. And that's probably something I'll institute. For this class, like I don't think I can take answers in D2L. I don't think that works, but I can like post the test like as a quiz in D2L just so it tracks when you open it. And then as soon as you open it, you have 2 hours to submit like to the Dropbox or whatever, something like that. I don't know. I got summer to figure that out. We're not doing that. We're just going to post like usual. I did have one student who asked, I think it was Christian, who asked if he could start today because he had kind of planned on that because of his work schedule. So I made a post that because of the classes that I have, this is the right, I didn't want to, because there's another Calc 3 class after you that I took over. I'm not going to write 2 tests, sorry. And so they're going to have class after this. And so I thought, let's just wait until tomorrow morning to post. So if you really were planning on starting tonight, I can email you personally the test. So just let me know if you would really like to start tonight. Otherwise, I'm going to release it at 8 a.m. tomorrow. I think I have a news post. I have a news post already. Did I make it already? Nope. Don't make a new news item. Sorry. I think I have the news post all ready to go to pop. That's what I'm checking here. Nope. Okay. Note to myself, post exam. I have the exam ready to go and I did test it myself. So I'll have that just pop up automatically at 9 o'clock. Ooh, Ryan, it's a good question. Are we going to take the 2 exam parts at different times? So when we were going to take the exam regularly, we're going to split over 2 days, which is what Ryan's talking about. It was going to be today and Wednesday. So we're going to do two exams, a little review in between. Obviously, that's out the window. So I have it posted as one single exam. I don't care if you take a break because I'm not timing you. I just don't want you to read the whole exam. Ooh, right, I forgot about that. Go back and do some more studying and then come back. So if you work on it for a while and you need to like have a coffee and have a snack or like whatever, have dinner and then come back and finish. I don't care about that. So you can kind of break it up like that, but it's not, I'm kind of assuming that you've done all your studying, you have all your notes, because this, did I mention the notes thing? I don't know if I mentioned that. So I decided at some point last week, open notes final. Okay, so I want to make sure you have you've done all your studying, you have your notes open, you got everything organized the way you want it, it's nice and clear, and then you sit down to take the exam. It's not like a classroom though. If you have to get up and go to the bathroom or whatever, take a break, that's fine. But I don't want you to do some studying, take part one, do a break, do some more studying, take part two. So I don't know if that answers your question, Ryan, but it's just a single exam. It's a single exam. And I would, if you want to do it straight, plan on a couple hours. I took 45 minutes. So I did some maple graphs too. I did want to start class today too, just kind of clarifying any other questions about kind of what to expect. Anybody else have any additional questions about what to expect? Anything kind of big picture-ish like that?
If you're graded like on
your audio is still a little rough, Max. I know, sorry. You're like super laggy. Go ahead and just type. You can even do a private message to me. It's all good. The joys of technology. So take your time. While Max is typing, anybody else have any other kind of big picture questions, grading, timelines? Anybody else? The submission deadline is midnight Wednesday, and so that's the submission deadline for like all of my calculus classes. So I have another Calc 1 and I have another Calc 3. So it's not going to be like Thursday at 10, your final grades are up. Sorry, that's not going to happen. But my goal is to have them done by Friday. That's my goal. Grades are due on Monday, so they'll be done by Monday at 5. But I would expect them much sooner than that. So I'm going to try to be working hard Thursday and Friday and have grades up by the end of the day on Friday. And I'll put a news post like usual. I'll put a news post, the final grades have been posted, etc. The other thing that I was going to say that I added to the final is I would like you to add a little statement here. Good question, Daniel. Just to ask you to write a little statement, just kind of handwrite at the top that like you did all your own work and that you only use the tools above, and just kind of sign it. It's just a little like reminder, like remember, like we're putting a lot of trust on you and you did all of your own work and only use these tools above here. Daniel asked about other Maple Graph links. I do have a couple. You could do the problems without them. And I wanted to give some flexibility to like, well, maybe a Maple Graph would help. So I kind of wrote the exam where there aren't vital. I added some images, also like still pictures in the exam, but I made some Maple links too. Were those hard? Like, is that a bad or a good thing? Like, why are there concerns? Like, what is there a reason why you're asking, Daniel? Okay, yeah, just wondering. Yeah, so I do have two that I put up. That I kind of was just to help you answer the question. I tried to have enough information in the test itself, but I did put a couple of those. So Max was asking about our grade and what happens when we're on the line, the border line. So I actually have a policy built in, which really is helpful this particular semester when it's been so crazy. So I have this policy, loading. I need a new image. This is like, that's getting so old. So this little extra thing here, kind of like I reserve the right to add 1% at the conclusion of the semester for students who like ask questions, come to my office, show they put an extra effort. It's not a penalty. You know, some students just like to sit in the back of the class and be quiet and don't participate unless called upon, and that's okay. So I kind of have this already built in that if you're close and you've worked hard and you come to class and you know, so it's more like an effort thing. So I think that's one that I'll be using this semester if necessary. By the way, let me know if the kids get too loud. I can switch back to headphones. Like I can hear them right now. That's like, the afternoon is tough because they're done with all their schoolwork and all they want to do is play Xbox, and we don't let them play Xbox all day. So then they get a little antsy. So I do have the headphones here if I need them. That mic is more like just like more localized. So does that answer your question, Max, about the borderline grades at the end of the semester? Okay. So I like to keep some buffer for that in there. Yeah, any other big picture questions or questions about the exam itself? Okay, let me know if you do have any. So I wanted to start kind of just talking about the final. We could do a couple things next. I didn't actually prepare an extra handout for 17.8 because it felt a little excessive. If anything, we could do one more example. I think we finished all the 17.7. It was just one example. We did the 17.6. So the rest of today, we can focus on any specific questions if you have some. So if you have homework questions you want to ask about, or you're reviewing like some older questions, we could do an extra divergence theorem question if you want. We can just pull up another one from the homework. So I'm kind of gonna open the floor. I don't know if you're more worried about more recent stuff and you'd like to do another 15.8 example, or if you've been playing around in the final folder here and you're looking at some old exams, and if you wanted to ask about those. So feel free to just type in or shout out like a topic or a specific problem, something that you'd like to look at for today.
I have kind of a general question. So just because like I've been kind of rushing through these past few sections, I haven't had the chance to really absorb like what's going on.
Sure.
So I just kind of want to like know like roughly like what's the difference between like Green's theorem, surface integrals, you know, just in the past few sections.
Yeah, I think the best. Are you up to date with the videos, Rudy, or are you missing a couple?
No, I've been through all the videos.
So I think the last one is really the key. So it's 17.8, because this is where it all like this is where I feel so bad, because the whole like all of Calc 3 is building up to now, and then we're like, okay, boom, boom, go, like the semester's over, and like it's so crazy. Normally we have more time. So it's 4 theorems. It's two versions of Green's theorem, and then Stokes theorem and Divergence theorem that really tie it all together. So Green's theorem is in 2 dimensions, and then Stokes and Divergence are in 3 dimensions. Green's theorem has circulation and flux. And so Stokes theorem has circulation and like 3-dimensional circulation, that's the 3-dimensional integral of the curl. And then the Divergence theorem has the 3-dimensional flux across the surface, or the integral of the divergence inside. So Green's theorem has it has a line integral, and it says you can do the integral of the circulation around the edge, and that should equal the double integral of the curl inside. So how much circulation is there on the outside should equal how much like rotation there is inside. And then Stokes theorem is the same thing, but in 3 dimensions. So you have some surface that has a boundary, it has to have a boundary. So that surface has a boundary. You can say, well, I could integrate all of the spin inside of here, all of the curl inside of here. I could integrate all of that. That's this over here, this surface. You're integrating the curl over the surface here, over that surface. Or I could instead find the circulation along the edge. And so that's usually how Stokes theorem is used, is usually you're looking for the integral of the curl over the surface, and instead you do the line integral, because the line integral is just along a path. That's usually the easier one to do. For Green's theorem, it depends. Sometimes the path is very complex, and it's easier to double integrate over the region. Sometimes the path is a simple circle, and it's easy to do a line integral over the circle. So that one, it kind of varies. You can do different ones. Usually with Stokes theorem, usually, like if you've been following along, the surface integrals are usually not fun. They are usually a lot of work. So usually if you can do a line integral, that's way easier than a surface integral. So then there's the flux form of Green's theorem, where you're looking for how much of the field is flowing across that curve. So you have that curve C, which is the boundary, and the flux is saying how much of the field is normal to that, how much is flowing across that. And so what you can do instead is you can add up all the divergence inside. And that's what Green's theorem, the flux form of Green's theorem says. So the divergence theorem is the three-dimensional version of that. You have some closed surface, now no opening. The Stokes theorem has a boundary curve. But divergence theorem, there's no boundary curve. It's a closed region, and you want to find the flux across that surface. So imagine like a magnet, right? And how much of the magnetic field is going out through, like, you ever seen these, I had them when I was a kid. I don't know if they still make them. There's the magnetic marbles, and all it was a magnet inside a plastic ball, right? So the magnet has a field. It's a magnetic field. And the plastic is like this surface that's around, and the field is through the plastic. So you might wonder how much flux is there, how much of that magnetic field is normal to that little plastic ball that's holding it. Well, what you can do instead, what the divergence theorem says you can do instead of finding the surface integral and how much is going out or in across the surface, instead you can find the divergence of the field inside and add up all the divergence inside the volume. And it's a three-dimensional volume integral. And that's kind of the point of the course, is these sections here at the end. So I don't know if that helps at all, Rudy, but that's kind of the key, is not just knowing the integrals, how to do them, and not just knowing the theorems, because you'll have the theorems written down, you'll have them nice and organized. But it's also about distinguishing, like, well, if I'm trying, like the divergence theorem is a classic one, if I'm trying to find the flux across a surface, and that's the question, it says, find the flux of this field across this surface. You remember, I really don't like doing surface integrals, because I have to parameterize the surface. I have to find tangent vectors in the u direction and the v direction. I have to find their cross product, and then I have to take the dot product of that with the surface and then integrate that over the UV region. So maybe instead I can just find the divergence of the field and integrate that over the volume. If it's a sphere, that's super easy. Just spherical coordinates, rho goes from 0 to whatever the radius is. And so it's also about kind of recognizing which version would be better. It's not just kind of knowing those integrals, but recognizing which one would be better. On the test itself, I kind of had a mixture. Some I did have you do the complete integral, and then I think on a couple of them, 2, I think, I asked you to just save a little time and just set up the integral instead of completing it. And I tried not to, like, I don't want to say like, well, if I had you do the integral, they'll all be easy. But I tried not to make any like super hard integrals that would, like, the integrals should be reasonable. The ones, whether it's surface or area or volume or line, all the integrals should be pretty manageable. Nothing too crazy. So I don't know if that helps, Rudy. It is a lot. It is a lot, and we're going fast.
It kind of clears it up a little bit. I just want you to know, like, the difference between all of them, and it's basically, yeah, they're all pretty much the same. It's just like which one is easier to do depending on like what information you're.
Yeah, and it's interesting that they're like, they seem very different. Like, why would a line integral around a boundary have anything to do with a surface integral for this surface? So they're like calculating different things, but those different things actually are equivalent, even though they're calculating different things. So yeah, that's, I don't know.
It definitely clears it up. Thank you, though.
That's good. That's good. I would encourage you to do as many of these as you can find to try to clarify, when to use what those regions are. A lot of it depends on your familiarity with the curve. There were some examples that we looked at where as soon as I see, like this one, it's saying, find the flow rate, right? That's the flux. That's the flux across this surface. When I see a surface that has 6 sides, I'm going to have to do 6 surface integrals, right? And that's something that hopefully it should be obvious to you. When you see that, like, wait, flux is surface integrals, there's 6 surfaces. I don't want to do that. There's got to be an easier way. I remember giving a question like this before and having students in a timed classroom exam try to do that. Right? And just, they kind of knew enough to be dangerous to themselves and their own sanity, because that was very stressful for them. Where if they had recognized, like, wait a minute, the whole point of these theorems is that there's multiple ways to look at it. Why don't I just find the divergence? Turns out the divergence is 0 and you're done. Now, I don't know if the test problem was just like that, but it was, flexibility with equivalent forms. All right, any other specific requests? Or some, like, a type of problem you'd like to see? I can pull up, we can try another divergence theorem one here if no one has any. Pull up our textbook here. Oh, I was going to mention, I did not get to your homework, but I did post, so I didn't get to your homework to grade it, but you still have it because you just took pictures of it. And the key is here under the content and the last unit. So under unit 5, there's a homework key. So I didn't get to grading yours, but you can look at the key there and kind of see how I did all those problems. So those are good. There's some good ones in there that I think are reasonable test level difficulty ones. So, all right, I'm going to pull up, I have the homework here. Let's just do, just for something to keep us busy here. I don't want to waste your time. Let's do another, let's try to find a reasonable, these get really hard really quickly. So here's some examples here. Cube. Did we do that one already? That's similar to the cube. Here's a sphere one. I'm worried on the sphere ones, because on the sphere ones, I'm worried that the surface integral will end up being easier than the double integral of the divergence. Well, it's interesting. If it's a sphere, the surface integral ends up being almost like spherical coordinates. And if you're doing a triple integral over the volume, it's probably spherical coordinates. That's interesting. So let's try, I don't know, we'll just try 18. And this as an example where I might say in the instructions, I didn't copy the instructions for this, but if we look at those instructions, it says use the divergence theorem. Right? Use the divergence theorem to compute the net outward flux. So that's kind of a dead giveaway. We'll write the formula for the net outward flux, but the point is to use the divergence theorem. So we're probably not going to directly calculate the flux. We're instead going to find the triple integral of the divergence. That's when I see those words, use the divergence theorem to compute the net outward flux. Oh, good question. Max is asking about, like, how do we know? First of all, I might tell you which theorem to use. That would be a bonus, right? Like this one. I might say use the divergence theorem, but it really depends on what you're looking for. So if you go back over to those theorems, you're looking for different things. See, for the divergence theorem, this F dot NDS, maybe you want to label that in your notes. That's the outward flux. So you're looking for the outward flux. That's a divergence theorem question. Or it's in 2 dimensions, it's Green's theorem. So in 2 dimensions, the flux is Green's theorem. In 3 dimensions, the flux is the divergence theorem. And then for Stokes, in the circulation form of Green's theorem, you're looking for the curl, like the spin kind of. You're looking for the net curl. In 2 dimensions, it's this partial derivative of g with respect to x minus the partial derivative of f with respect to y. You can find the curl. You can instead, now you can ask for either one. Those are going to ask you for circulation. The left side here is circulation. Circulation, circulation. Those are both circulation. This one is in 3 dimensions, but it's still a circulation on a path. And then the right side is the integral of the curl. So it's really about, if it doesn't tell you which theorem to use, it's really about what is it am I looking for. If I'm looking for the flux, that's either the flux form of Green's theorem or it's the divergence theorem. That's what that one's giving me. Does that answer your question, Max? Okay. All right, so let's go back over. There it went. All right, I forgot to flip my monitor around here. Okay. Sorry. Okay, we're supposed to find the net outward flux. And it says to use the divergence theorem, so I'm going to say, well, instead, we're probably going to triple integrate over the region of the divergence of f dv, sorry. And the divergence of f is the simpler one. It's the dot product of the gradient vector with the field. So it's the partial derivative of f with respect to x plus the partial derivative of g with respect to y plus the partial derivative of h with respect to z. That's 2x. Oh, nice. Plus 0 plus 0. Nice. So that'll be the triple integral over the region, 2x dv. And now we just have to figure out what system we want to use, what coordinate system, rectangular, cylindrical, spherical. And that's going to be defined by your region, whatever is easiest for your region. If you have a cylinder, something cylindrical, you know, a circle in the xy plane, but then a cylinder up, hey, use cylindrical coordinates. If the only time you're really going to use a spherical coordinates, is when it's a sphere centered at the origin. So that's really the only time spherical coordinates are helpful. You can force other graphs into spherical coordinates, but it's like makes it worse. So the only time you want to do spherical is if it is a sphere centered at the origin. Then that's a way easier system than rectangular or cylindrical. And then cylindrical, I'm only going to use that if I have like a circle in the xy plane, because that makes the cross, like, you know, z goes up and down. So I'm only going to use that if it's a cylinder. It doesn't need to be, I don't mean cylinder like can. What I mean is like there's some circle part of the base. Maybe the top is a wave or something, like that's fine. But it's like cylindrical at the base. That's when I'm going to use cylindrical coordinates. But this one though, this is just the first octant has the planes x equal 1. So that plane y equal 1, z equal 1. It's just like a unit cube. So that's definitely going to be rectangular. Rectangular would be the way to go there. So this is actually not that bad. All we have to do is integrate 2x. X, we can, that's d. It doesn't matter what order because they're all 0 to 1. Does not get much easier than that for a triple integral. Oh, hold on. Like trying to upload the video that just got processed here. Okay, I don't know. Do we need to do that triple integral? I don't think so. Right, Christian's like, hopefully they'll all be this easy on the final. I will say that some students will not recognize that those instructions where it says, you know, or maybe I'll just say compute the outward flux. And if you don't have good notes, you might say, oh, outward flux is a surface integral, right? So yeah, that one was maybe a little too easy. Should we do it? Let's do another one. I don't know. I feel like we need to do a sphere one. I'm a little worried, but we can at least try to set it up. Let's try this number 21. Shouldn't be too bad. I don't know, famous last words. So again, we're looking for the outward flux. And we're gonna probably set up a triple integral. All right, the divergence of f will be the partial derivative with respect to x of that first, so -2 plus partial derivative with respect to y of the second one is -1 plus partial derivative with respect to z of the third one, also -1, so it's -4. Nice. And so it's not too bad. So it's just a triple integral over the region. Oh, this is even easier than it sounds. Of the divergence of f, which is -4 d. Why did I do dv? Or sorry, dA. It should be dv. I apologize. I had dA written up here. It's three-dimensional. It should be dv. Definitely should be dv. So this one is actually even easier than the last one. We don't even need to integrate. Does anyone know why?
Because you're not like integrating a function, it's just a constant, right? So you can bring the constant out and then it's just that times the volume.
Yeah, right? So that's exactly it, Michael. So the triple integral of dv is the volume. So this is just -4 times 4/3 pi r cubed. What is our radius? 2. -16/3 pi times 2 cubed. That's 8. Whatever 16 times 8 is. 128. So not bad. Look at the two that we picked. The two that we picked ended up to be pretty simple. Again, when we go back to the theorems, both for Stokes theorem and the divergence theorem, one of the integrals is typically much easier than the other one. And so for Stokes theorem, finding the integral of the curl is a surface integral. It's usually much easier to use the line integral. And for the divergence theorem, finding the net flux is a surface integral. It's usually much easier to find a triple integral of the divergence. So typically, that's the way it ends up. We did, be aware, We did have some in the homework where it was like verify the theorem is true and do both. And that's a way for me to kind of have one problem, but give you, can you actually do a surface integral? And can you actually do the triple integral or do the line integral, and kind of test your ability within that? So read those directions carefully. That's possible where we will have you do both completely. And it's a nice confirmation for yourself, because if you do have to do both, and I guess you could choose to do both for yourself just to check, but you should get the same for either one, right? That's kind of the whole point. Okay, I think that's good. I don't want to do too much more of that. I was talking with my colleagues when I was trying to figure out what can I do for the rest of the semester, when I was realizing where we were and what we had left, and we've really done great, because the goal that we kind of realized was just make sure you have these big ideas, that they have this equivalence between these two things. Daniel's asking, can we reference examples in our notes when we're doing surface integrals? That is a fair point. Your notes are open, so it's open notes. Just read carefully. I may ask you to kind of repeat some derivations and kind of show it again, that you're able to repeat that process. So just be aware that that is a possibility where if it says something like that in there, then I want to see those parts. If there's a surface integral and you have open notes, you can say, well, we already did this derivation. I know what the parameterization is, and I know what the magnitude of the cross product of TU with TV is. Then if there's no additional stipulation on there, then just referencing it would be reasonable. So what I'm saying is, if we had to do the surface integral here, I'm not going to. It will be a lot more work. But we already have a parameterization of a sphere. We already have R of UV is, what would it be? I don't know if I can do it all. I think it's A squared. I can't even remember. I think it's A sine U sine V. We did it so many times. I don't know if I can remember it right now. Cosine V and then 2 cosine U. Is that close? I don't know, that looks familiar, right? Something like that. So we don't need to derive that again. We already have that. And given that, we already have this magnitude already. So if it doesn't say derive it again, then you can go ahead and just reference that example. Yeah, that's a good question, Daniel. Okay. Any additional requests right now? This is our last live session. So are there older things that you wanted to look at from earlier in the course? A particular topic maybe? It's quiet today, huh? Everybody's like, man, just ready to be done.
Yeah.
I do not hold that against you whatsoever. Not at all. Well, and if you think about it, normally we would be done, right? We'd be taking our test right now. We'd have a little take our breath tomorrow and then be taking our tests on Wednesday. And so we're actually having a little extra today because we lost like a week and a half. I don't know. I can do some more stuff. I can just pick something to do. I'd rather do things that you have questions about. Tell me this, what do you have planned once everything's turned in? Do you have a celebration planned? I'm hoping the rain stays away because it's supposed to be not warmer, but but maybe rainy this weekend because I got like new patio furniture. We have a big enough patio where we can have friends over and like stay on opposite sides of the patio and like have a fire. Like that's what I'm looking forward to. Ooh, fishing. Fishing. I like it. John, where do you go? Where do you go and what do you fish for? I used to fish for trout when I was a kid. I grew up in southeastern Minnesota, and there's a lot of trout streams there. So I used to do some trout fishing, rainbow trout. My mom's more of a pan fisherman though. She likes like little sunnies. Sure. That's cool. Anybody else have like celebration plans? End of semester? Going to work? Is anybody still like how many people are still working?
I just went back last week.
Okay. Donut party. Nice. Oh, where do you work, Rudy?
I work at PetSmart in the grooming salon.
Okay. I heard that
Yeah, the grooming salon's finally opened up. I'm not happy about it too much. I personally think they should have stayed closed, but
yeah.
oh well.
Yeah, and then you as an employee don't really have an option if they're open.
I mean, I kind of had the option, but like if I didn't, then people would be screwed over with scheduling, and I didn't want to be that person. So
yeah, so this came up with our college. Yeah, I know, John, we had talked about, like things were getting crazy at work. Like you never really stopped and almost was more busy, right? But like we had this come up at our college, like what happens if we open in the fall and I'm an older individual or I have an immune system that like I don't want to risk exposure. They basically said if the college is open, it's your job. So like you have to come. It's your job. Now I don't think the college is going to be open like 2,000 people on campus every day. But they were I know some employers have been that way. Like we're open. This is your job. So yeah, that's tough. But some people it's good too. Like it just go a little stir crazy sitting around the house too, and you got bills to pay and all that. So that's cool. All right. I don't know. I don't want to waste your time. I know you have studying to do. Your time might be better spent. What is in his mouth? What does he have, Natalie?
Toy.
just holding a toy. This morning we had a pet sharing in our calculus class. We had like one student. She has two little. I don't know what they are. I should know. It's like It's a breed dog. It's a certain breed, and she had two of them. And they were like the only time they would be quiet was if she was holding them. Oh, look at Kyle! Oh my gosh, that's a good-looking dog. That's so good. I have cats, but they like avoid me. I don't know where they are. That's funny.
I don't know if you could see the other one.
Oh, just like lazy. That's cute. They're beautiful dogs.
Thank you.
Yeah, my wife, I shouldn't see this. My wife wants to get a dog. I don't want a dog. We had them when I was a kid, and it's just labor intensive. I love dogs. They're fun. I like to go visit other people and play with their dogs and then go home. So it's like some people back with children, they like to hang out with other people's kids and then go home. Yeah, I hear you, Michael, about hopefully it's back. I don't know. I just don't see the way the college is talking right now, and like some of the schools, like U46 is already talking about planning for partly online, and I don't know. Like I would personally feel comfortable coming to campus for myself, but I'm not really at risk. One of my colleagues did not want to be on campus because he has like bad lungs already. And he's like, I don't want to be there. So I get it. Yeah, it's the labs that are the big deal. And those are the ones that are more likely to be on campus. And like say we're under the 10 people or less kind of restriction. What they would probably do is cap class sizes at 27 and have 3 different times for classes of size 9 to come. Do you know what I mean? like, or maybe cap class is at 18. And so you have 2 groups of 9 that meet, different. So then you're just limiting the number of people that all come together at once. That's kind of some ideas that have floated around. And so then classes like ours they just wouldn't even bother. It's just not. Maybe we'd have a test week or something, and we'd have 2 different times you can come in just to take your test. And that way we're not worried about video recording people and timed all this stuff. And, we just come in and book a classroom for a couple hours and only have a certain number of desks in there and everybody's far apart. And I don't know. We just got an email today from the vice president that said they're going to try to decide by June, like early June. So there's some other stuff here. There's some like faculty stuff in here that you don't really care about. There's the no harm grading, textbook returns, textbooks. This is kind of cool. Like I would probably do this for fall. If we are online, they're letting people do this for spring, is I would just email my notes to the copy center and they'll print them and mail them to you. So that's kind of cool. So they're offering that. So here's the fall update. So this chief academic officers, that's a statewide committee. That's people all across the state. And they're having a meeting this Friday. They're going to come up with some guidance early June. K through 12 system may not be receiving state guidance until early July. And then we're not gonna wait that long. We're not gonna wait that long. So that's why they're gonna like early June we should know. Early June we should know. All right. That's a good question, Max. That's one that like is easy to forget, that right-hand rule, and sometimes you forget and you just get it right. So the key is, Max is asking about this right-hand rule. When you have a surface, so here's some surface, and it's usually outward normal vectors. So this is Stokes Theorem. You have a surface with a boundary C. So this is the boundary here. Boundary C, surface S. So you have that boundary C, and the problem is you're going to have a path for it, and every parametric path has an orientation, has a direction. Which way is it going? And there's 2 options here. It could be going this way, or it could be going this way. And either one are reasonable. Just depends on the problem, what the purpose is, and maybe you're given an orientation. But if you're not, which you usually aren't here, you have to pick an orientation. So the right-hand rule, I need like this icon, like from your, I need this. I need that on the picture, like on the screen. I need to show that somehow. So the idea is you're wrapping your hand like with the path, and your thumb should point in the direction of the normal vectors. So your right hand is moving with the path, and your thumb points in the direction of the normal vectors. So the problem is if I follow it this way, then I'm pointing down. So whatever path I come up with, it better be oriented that way. Then my thumb will point up in the same direction as the normal vectors. It will describe to you usually in the problems about the orientation of those. It'll say like outwardly facing normal vectors. Like it will tell you which direction is the normal vectors are facing. Does that help? Yeah, so we use it like the right hand, like the cross product, right? So this is kind of like that. This is like a different related right-hand rule, but it's not the cross product of A and the B, and then the cross product faces this direction. But it's kind of like that, but it's different, yeah. All right. What else was I gonna say? I talked about grading. Grades will be up. Grades should be up by Friday, the end of the day on Friday. Hopefully I want to be done so I can enjoy the weekend. Oh, I sent out an email today about the math contest. Professor Cunningham has all those records in his office and it hasn't gone back. And so he'll let me know and we'll confirm, but I don't want to wait for him. So if you took it in my office, I have you already. But if you took it with the contest, just shoot me a quick email and say I took the contest because we were given some final exam points. So be sure to email me that. All right. Any last questions?
Will D2 will still be up like on Friday so we can see our final grades?
Yeah, let me double check. I always extend the deadline. So let me just make sure I've done that. I usually just have go to the end of the month. Edit course. Like, I don't know why. I guess I know why the default is to end right away, but like, I don't care if you keep going in later. So let's end it. Thanks for bringing it up. I'll end it on May 31st. So then you'll be able to access it all the way until then. Yeah, thanks. Good idea to put that in there. Any other questions? Okay. If you have other calculus-related questions, feel free to ask anytime today. I'll check my email a couple times today. I have another class from 4 to 6, their last class. Long day for me, but it's all right. And then tomorrow, the exam. Once the exam is up, I don't want to do any additional like calculus review. But just like with other exams, if you have a clarification question about the exam itself, feel free to email me or even post in the Discord chat so that everybody can see the question. I don't mind that. Exam clarification questions are fine. But what I don't want is for you to look at the exam and realize, oh, or maybe you didn't even look at the exam, but I don't know. And so I don't want calculus questions tomorrow afternoon or Wednesday morning, just because I don't know if you've already looked at the exam and that's why you're asking the question. So just to remove any of that uncertainty, feel free to email me any questions today, because I can even reply tomorrow, because I know you won't have seen the test yet. Do you know what I mean? Like, you can email me at 6 a.m. That's fine. I won't reply till later, but I'll have known you hadn't looked at the test yet when you had the question, so that's fair. So just as soon as we hit that test release time at 8 a.m., then we'll call. No more emailing me questions after that. I know not everybody is here, but I really want to say, like, I'm just like super impressed with how hard everybody has worked this semester. Like, trying to do all this from home, and suddenly in the middle of the semester, you're trying to watch videos and you're trying to do tests on your own. And I don't know, I've just been really impressed with how everybody's doing their best to keep up. And it's hard. We've talked about how it's like I can see like my number of quiz submissions or homework submissions goes from like 27 to 24 to 22. And like, it's just normal. I can't blame people. It's hard to keep up, but like, we're really working hard. And like, I don't know, we've lost a couple people who haven't been able to continue, and I don't really know why, but I think most people are going to be okay. And it looks like people are still going to like pass, and some people there's going to be a good number of A's and B's that are well-deserved. And I just couldn't, like, I can't tell you how proud I am of how hard you've all worked and really made it through. And so I think that's really impressive in these circumstances. So I just wanted to say that. Nice, Michael. Yeah, Max is like, man, where is that? There was some movie about that. It's old. You're too young. There was some movie. He had like a remote that he like paused real life. It's like, where's the pause rewind button in real life?
Oh,
right? What's that?
That movie was Click.
Click, yes.
Adam Sandler in it or something.
Yeah. I remember that. Yep. Okay. So that's like, it's like, yeah, it is nice. Multiple people in the feedback form said that, it really makes it like a real class to kind of have that interaction, but it's almost better the fact that you can pause and rewind and play that part again. So I'm really glad that has worked. I'm really glad this has gone well. Thanks for that comment, John. I think, you have an advantage that I have a lot of experience and stuff that people don't, like what was I going to show here? Like I bought a freaking green screen and I have extra lights in my office that I can use. I don't know if you can see these, but I have actual extra lights. You see that big light over there? And a big light over here that make the green screen work and make it look clear and make me look lit. And I can't get it lined up again. And I've done lots of videos like this before. And so I have this skill set that not everybody else has. And so I don't, like, I feel bad for some of my colleagues. I know they would love to do some of this and just can't. They just don't know how. You know, I'm not doing it for my other calculus class. I'm using one of my colleagues' videos, and she just has an Apple iPad and has a little pen and does notes like that. And it's fine. It's good, but there's no camera. You know, it's just different. It's just different. And I'm glad that it's been good for this class. And I know it hasn't been the same for everybody else. Some people aren't even hearing from their instructors. Like, I don't know if that's happening to any of you, but I can't imagine. I feel worse for the people who are much older and have no tech experience. Like, they did not sign up to be online instructors. So I got a little emotional there. Whew. All right, that's it for today. I got to go. I got some other things I got to do before this 4 o'clock class. So thanks again for a great semester. If you have any other suggestions you want to make for fall, there's a link to the form. I want to email that out to everybody. There's been really thoughtful comments so far, and I really appreciate them. Otherwise, good luck on the rest of your tests. Good luck on ours, of course, too. Ours is the most important. Make sure your priorities are set straight. Right? Yeah, but otherwise, hopefully I'll see you in person again soon. I know some people are transferring, but hopefully I'll see you again soon. Okay, that's it. Bye, everybody.